So this video goes out to Max, Zer, and anyone else who likes a laser tutorial. As you can see, I have a laser coming out my character's head, and this is just scripting, no sound, no animation, no UI bar for the ability, even though this is a laser ability. Um, and yeah, so it's gonna be a two-part series. This just being client, and the second part being server, handling it for every client. And if we hit 10 likes, I would drop the second part sooner than later. If not, well, we're just gonna have to wait on it. Until then, let's get to it. Okay, so for us to get started, you boot up your base plate, and we're just going to need one script for this client. So open up your Explorer panel, going down to Starter Player Scripts, and insert a local script. So here we're going to go ahead and get the services that we need, starting with players. So local players equals game get service players. We're going to get the replicated storage for future reference. So local replicated storage. Jeez, I can't type. Equals game get service replicated storage. Then the run service, contact action service, and user input service. So okay, once we got those, we have our services. So let's label that at the top. And now we're gonna need our references, which is the character, the player, and camera. Jeez. Now that we got that, we're gonna go ahead and make our configurations variables. So these are kind of constant for your laser. So let's go ahead and comment that in. First is max distance. How far do you want the laser to be? So next, we want to get the laser thickness if you want a specific preference. I'm gonna make mine 0.3. And last, we want to get the damage interval. How much you want the laser to damage said player or any NPCs. This case is going to be 0.1, so a tenth of 100 of a player's health. Even though this is the client version, they're not going to matter too much, but in part 2 we will be using these configurations. But right now we're mainly focusing on the max distance, but we're just going to leave this here for the next video. So moving forward, we're going to get the player's character, the local character, well, local player character equals player.character or player.character added weight. And then we're gonna get the humanoid. So local humanoid equals player character weight for child humanoid. Next, we're gonna get the state for the laser. So first we're gonna get if the laser is even active. So local is laser equals false. Then we're going to see if a laser is apart. So local laser part equals nil. And then we're gonna get the damage time for the laser. So local last damage equals 0, right? Now for this laser video, right, this laser ability, we're gonna need to do a raycast so the laser knows where it's starting and where it's shooting from. Like it's literally a ray, right? So making a new section, raycast. We're gonna get the raycast parm. So local raycast parm params, or whatever you like to call it, equals raycast params.new. Now, if you don't know what raycast is exactly, params, I know I'm saying it wrong, but that's okay. Essentially, we're making it where whatever's inside this table, particularly what it filters out and what the raycast will ignore and continue shooting its ray. So here, I want to do raycast filter, well, raycast params dot filter. Filter type equals enum dot raycast filter type dot exclude. So what are we ignoring exactly? And then we're gonna do raycast params. Oh, my bad. I'm typing this wrong. Raycast params dot ignore water, because obviously we want it to ignore the water. If you guys have Roblox water inside your game. So we're gonna leave this here and we're definitely gonna come back to it in the future. So we can know what we're excluding within the raycast. So we're just gonna leave that. Now moving forward, we're gonna get the character update. So for the people who knows how to script, when the game boots up, right? For example, this local script, the code, Lua will read it from top to bottom all the way down, right? And obviously we got the player's character from it loading in within the game and then the humanoid. But let's say you were to like reset or your character dies, it's still tracking your first character respawn. So when your character do spawn back in, it's only tracking your first character spawn in, even though you spawn in, even though you respawn as your new character. So to fix that, we're gonna make a function. Let's actually section this out. So character update. So we're gonna make a function called update character, right? And inside the params, we're gonna give it an argument called character, which is a model. And in this function, we're gonna update the player character variable. So when a character do reset, this also updates to the latest player's character. So we're gonna do player character equals character, and then humanoid equals character, wait for child, humanoid. Right now, in our state is laser is false, we're gonna make sure that's false again, right? Because is laser is basically saying if the laser is like active, right? And if the last character that you was playing as had a laser, we want to make sure that laser is no longer there. So just making sure that variable is like back to false. So is laser, well, actually we don't gotta do that. This is laser equals false. Now here we're gonna make sure that laser part is also destroyed from the last character, from your last character that you was playing as. If it's not destroyed, then we're gonna make sure it's destroyed. So if laser part, then laser part destroy. And then under that, we're gonna do laser part equals nil. Great, now that we made this function, this can be called every time, whenever we need, but we're just gonna call it exactly right after, right? So whenever the player character is added again, right? We're gonna make sure that function is called, so we update the player's character and the humanoid. So player called, character added, connect, update character. And there we go. Okay, so moving forward, we're gonna now make some new functions. So starting with the first function, we're gonna do the laser creation. So let's do laser creation. So here we're gonna do local function, create laser, and inside this function, we're gonna do if laser part, then return n, right? Because if the laser part is already like made, then we're just gonna return. But if this is false, so the laser part doesn't exist, then we're gonna continue with the function. So here we're gonna do our little params. So local part equals instant.new, which is a part. And here we're just going to be making a new part, which is going to be the laser part. So yeah, go ahead and just update your properties. So local part anchor equals true, can collide equals false, can query, it doesn't really matter. You can make that false as well. Can touch is false, transparency 0. The name will be laser, the parent will be inside workspace. And last but not least, we're going to get the size. So part dot size equals vector3 dot new. We're going to do laser, um, sorry, we're going to do 0.2 comma 0.2, well, sorry, 0.2 comma 0.2, yikes, 0.2, right? And we're also going to do the color and the material. So part dot material equals enum dot material dot neon, and part dot color equals color3 dot new. We're gonna make this really red, so 1 comma 1 comma 1. If you don't want to do a color value, you can always just remove that and make it a brick color. So we can always do part dot brick color equals enum dot brick, well, sorry, enum dot brick color dot new. Yeah, I don't know why it didn't pop up when I typed it, but and then inside this little section, right, you can type in the brick color you desire. So like you can go back to workspace and then click the any part, or just insert a new part. It doesn't really matter. Go to properties, click brick color, and then just type in the exact name you're looking for, right? For me, it's going to be really red, but it doesn't really matter. Brick color or color3, your choice. Last but not least, we're going to do laser part equals part, right? So now we're updating the laser part to be this part that we just created. Now, if you are wondering to make the laser a certain thickness for better, what's it called? Easy adjustable. That's why it didn't pop up. I left the space. Yeah, obviously you can just change the thickness from here. So I'll go back down and change this. So laser thickness is X and the Y as well. And then the Z will be 0.2 because the Z is what stretches the laser from the player's position, your player character's position, and to wherever you're aiming at. So we're leaving that at 0.2 and it just updates throughout time, right? So moving forward, we're now going to do laser removal as the next function. So making a new comment section, laser removal. So local function destroy laser, And inside this function, we're going to check for the laser part again, right? So if not laser part, then return n. So if not true, if we can't find the laser part, that means it's already destroyed. But if we do find it, then we're going to continue, right? So here, something simple, laser part destroyed, and then laser part equals nil. Now, now that we got the creation for the laser and then the destruction of the laser, right? We're now going to move on to the player's input. So a new comment input, and then we're going to make a new function called local function handle input, right? Here we're going to do for the arguments, we're going to need 3 arguments because this is going to be attached to the contact action service. And if you know anything about contact action service, it needs its action name, input state, and its input object. So we're going to do that. We're going to do action name, input name, and, well, not input name, input state, and input object, right? And inside these, we're going to give it an N so there's no more pop up. Inside these, we're going to give it a type of what it's looking for exactly. So action name is going to be a string for the contact action service. Input state is going to be user input state. So enum dot user input state. And then the input object is going to be, well, input object. Like, that's really it. When it begins, when it ends. Now that we got our arguments, we're going to go ahead and start with the input state. So if input state equals enum dot user input state dot begin, then, so whenever the player start with their input state, right, whatever button or whatever thing you assign to it, we're going to then check if is laser, right, if there's already a laser. If there is, then return. But let's say there's not. Now we can continue. So is laser is now true. So we know that the player finally created, not created, the player finally input went through, and like the laser is the first time them creating it. And so we're going to create the laser, right? So now that we create the laser, we're going to go ahead and do else if input state equals enum dot user input state dot end it. So whenever they stop doing the laser ability, then we're going to do is laser equals false, then destroy laser, right? Something simple, nothing too crazy. And that's going to be the function that handles the input state. And for better visual purposes, we're just going to drop this down so you can just see each action line by line. I mean, each argument line by line. Now that we got that function going, we're going to go ahead and add this contact action service to connect to this function right here, right? So grabbing the contact action service, and then we're going to bind the action. Here, we're just going to call it laser, right? And we're going to connect this to handle input, and create touch button is false. I'm assuming y'all don't want this mobile. We're just worrying about computer PC. And we're going to make this left mouse click. So enum dot user inputs type dot mouse button 1. So whenever the player left clicks, then it will handle creating the laser and everything like that, right? Cool. Now moving forward, here is where we're actually going to start making the laser update as the player like moves along and everything like that. So here we're gonna do update laser, and we're gonna start using the variables like if is laser is there, if it's true, if it's false, etc., etc. So now we're gonna use the run action service. Run service, my bad. Run service dot render step connect function. And every render, every frame is where we're gonna update the laser to see if it's like actually active within the ability with the character wanting to use a laser, right? So if not is laser, then return in, right? Now, if not laser part, then return in, and if not camera, then return in. So if we don't have these variables, like passing this check, then the run service can't properly update the laser. Now moving forward, we're gonna get the player's character's head. So let's get that. Comment right here, getting player's character head. Then we're gonna do local head equals player character find first child head. And if not head, for some reason, if we can't get their head or not head as a base part, because I'm assuming this is just R15 and R6, not no custom model, then return in. Now that we got the character's head, right? Now that it passed this check, we're gonna go ahead and get the laser's origin, because that's where the laser's coming from their eyes essentially. So commenting right here, origin, we're gonna do local origin equals head dot position. Now that we know where we're placing the laser at exactly from its start point, we're gonna now need to get the player's mouse. So like their mouse positions, like whenever they're moving around their mouse, the laser follows it along the way, right? So right under origin, we're gonna make a new comic section. Um Getting mouse ray position. Well, nah, getting mouse ray from camera essentially. So local mouse position equals user these user input service get mouse location, and then we're gonna get the camera's ray from its mouse position. Excuse me. We're gonna get the camera's mouse position from the screen. This is gonna be slightly advanced for the ones who don't know viewport. But don't stress. So local ray equals camera colon viewport to ray, and we're gonna get the mouse position dot x and then mouse position dot y. Now, just to give you like a little class right here, right? This viewport point to ray, it's essentially your viewport, like literally what's on the screen right now. So if I were to like click play, this box that I'm making like this highlighted box in, that's essentially the player's screen. And since the viewport is a 2D, like, 2D view, like view, it's getting the X, which is left and right, and the Y, which is up and down, right? Top to bottom. And if you know geometry, you got the 4 points, if I remember correctly. But from left to right is negative, positive, and then top to bottom is positive to negative. But we don't have to dive into it right now. We're just getting a viewport to ray from the mouse position from the camera, right? Now, moving forward, we're gonna go ahead and get the what's it called? the array params, and we're actually going to insert a table into what we're excluding. So we're going to do ignoring table, and inside here we're going to do raycast params, right? We're grabbing it back, and then we're going to filter descendants instances. And here, this is what we're going to be ignoring. So this is why we saved it from above. We're going to be ignoring the player character and the laser part, because if we don't, then our own laser can hit our character and our laser can hit itself, which causes issues. We don't want that. Now that we got that out the way, we're going to go ahead and do the results for the raycast. Like, what does it return back with the ray that it's hitting? So local workspace colon raycast. Whoa. We're gonna do camera dot sorry, camera ray dot origin, and then camera ray dot direction. And we're gonna do that excuse me. We're gonna make the camera ray direction times it by the max distance, right? Or wherever your max distance may be. And then we're gonna add that to the raycast params. One sec. Okay, so I just realized why it's, my bad. Okay, so I see why it's underlined red. It was bothering me. I just forgot to give it a equal sign. So yeah, local results equals workspace colon raycast, camera ray dot origin, camera ray direction times it by max distance, and then that's going to be within the raycast params, right? So now moving forward, we're gonna get the aim point. We're almost done. So local aim position equals, aim position is going to be a vector 3. We're going to leave this variable here and come back to it later. So if results, right? If the results is true, then we're going to give it the aim position. Local aim position equals results dot position, else aim position equals camera ray dot origin plus camera ray direction times out by max distance. Now, moving forward, we're now going to get the ray from the player to the aim position. Now that we got it from the results of where we're aiming at, and if not, then we get it from the camera direction, just throwing it out there. So, making a new comment section, ray from player to aim position. Now we're going to do local offset equals aim position and minus that by the origin, right? And then we're going to get the distance. So local distance equals offset dot magnitude. So just to give you guys a better understanding, the distance is just, this is just a distance of how far it is, and the offset is basically offsetting the array on where to exactly put it at, right? Because it's basically just placing that ray into that midpoint. But you don't gotta stress too much about it if you're not too much into math, right? So if distance is less than 0.001, then return n. Now we're doing this as a safety check because if the laser's like, let's say we're standing right here and the laser is exactly on our character leg, or like it's like way too close to our character. That's very unideal, right? Like we're shooting a laser and we put our mouse exactly like somehow in our chest, and the laser goes like from there to there, right? That can cause a few issues, and which is why we're putting this little safety check for the distance. If it's like some reason too close where it can cause issues, then just stop it, right? Just save itself. But let's say it's not, right? Then we're gonna do another ray cast for the laser exactly. So second ray cast in the comment section. Now we're gonna do local laser results equals workspace raycast. And inside this, we're gonna do the origin, direction, times, max distance, and then raycast params. All right. I do. Sorry, that's why I forgot. Under distance, right? Where we did the safety check, we're gonna make a new variable called direction. So local direction equals offset dot unit. And now, yeah, that line went away. So lastly, the final stretch, we're gonna get the target. So local target equal, well, target is gonna be a vector 3 because it's inside workspace. And now we're gonna do if laser results, then target equals laser results dot position, else target equals origin plus direction times max distance. So if we don't have a target, right, then the laser just continue to shoot in a sense. But all right, cool, whatever. Um, Now we're actually gonna update the laser itself, which is the visual part. So we're just gonna do comet laser visual visualization. That's cool. Now we're gonna do local final distance equals target minus origin dot magnitude. Now we're gonna get the middle, which is local origin plus target, divide that by 2. And finally, we're going to update the size of the laser. So laser part dot size equals vector 3 dot new laser thickness on X and Y, right? And then we're going to update the Z so it looks like it's stretching from wherever you're aiming at. It's going to be final distance. Now we're going to get the part. So laser part, again, get the C frame equals C frame dot look at where to place it at exactly. So we're going to do the middle and target. And yeah, that should be everything. So if we go ahead and play test, we have our laser. I know this is white, make it red. But yeah, this is all local side, as you can see. As long as you're holding down the left mouse button, then the laser will continue to shoot out. It's too close, you notice the laser is like kind of inside the character, but you can see the shadow that it's still there. But like, yeah, it works, which is pretty nice. Now, if you enjoy this video, this is obviously the client side, so part 1. And if we hit 10 likes, then we'll make a part 2. on server replicated for all the clients to damage each other with said laser ability. And yeah, I hope you enjoyed this video. It was pretty straightforward, very easy and understandable. And while you're at it, comment down below if you'd like to see anything. And while you're down there, click the subscribe button. It really helps me out. It's free. Like this. This is free. And yeah, thanks for watching. I'll see you next video.